humans. We're going to do B3 today. We're going to be talking about function evaluation and graphing. So our objectives are that we're going to evaluate and graph, and which means we have to label functions. So a little bit of vocabulary. Evaluate basically means find the output, so potentially a y, given an input, and typically we talk about input as x. So when we use functions to represent data, so then we want to use our functions to predict. So functions are used to represent data or numbers. They're also used to predict what's going to happen at a certain value. Okay? So let's say I'm given the function f of x is equal to x plus 2. Remember, x is the input. F of x, which is the same thing as y, is going to be the output. And I want to evaluate the function at f of 3. So that says find the value of the function when x is equal to 3. There's a lot of words just by writing f of 3. So basically what's going to happen is I'm going to take this 3 and substitute it into the equation everywhere there's a 3. So f of 3 is going to equal 3 plus 2, which is 5. And then I would report my answer well, and I would write f of 3 is equal to 5. Okay? So that was a nice, easy, polite example. So let's do our first bigger example. Okay? So we're going to be given that f of x is equal to x plus 2, and I want to evaluate f of 2, f of a negative 2, and then f of 3z, just to get a little bit crazy. Okay? So this is my function, and I want to evaluate it in 3 different places. So I always write my function down when I start just because I'm a little bit anal and tend to write things more than I should. And then I'm going to do f of 2. So 2 is going to be substituted in for the x, so I'm going to get 2 plus 2, which is equal to 4. And so then I'm going to write f of 2 is equal to 4. And then I'm going to do f of a negative 2, which is a negative 2 plus 2, which is 0. So f of a negative 2 is 0. Now this is a little bit crazy, f of 3z, which means this gets substituted into the function everywhere there's a variable, so it's going to be 3z plus 2. Like things play together, these aren't alike, so I'm going to say f of 3z is equal to 3z plus 2. So when you're taking assessments for me, your work will go, the assessments are in 2 columns. Your work is going to go on the left-hand side, and then your solutions or your answers are going to go on the right-hand side. So this would have gone on the left-hand side. You write your whole answer down on the right-hand side, just so that it's nice, neat, and organized. And sometimes it's all about me because it makes me able to grade faster. So for the second example, it's going to be the same basic type of problem. So this time we're going to be given f of x is equal to x squared plus 2x plus 3, getting a little bit more entertaining. And then we're going to evaluate f of 2, f of a negative 2, and then f of 3z. Okay, so we started nice and polite. Now we're just going to have a little bit more fun. So if I write my f of x down, I also do this because it puts it right at the top of my work, and then I can see where I'm going to substitute my numbers. So 2 is going to be the input going in everywhere there's an x, so it's going to be 2 squared plus 2 times 2 plus 3, which is 4 plus 4 plus 3, and that's going to give me 11. And then I would write my solution, f of 2 is 11. If I do f of a negative 2, it's going to be a negative 2 squared plus 2 times a negative 2 plus 3. A negative 2 squared is a positive 4. 2 times a negative 2 is a negative 4 plus 3. The 4's cancel and equal 0, so my answer is 3. So f of a negative 2 is 3. And then f of 3z, now I substitute the 3z into the equation everywhere there's an x. Parentheses are important, so it's going to be 3z squared plus 2 times 3z plus 3. If I do this math, when anything is inside the parentheses, that means that the squared applies to everything inside the parentheses. So 3 squared is 9, z squared is just z squared. 2 times 3 is 6. There's the z plus 3, and then I would report my answer. F of 3z is 9z squared plus 6z plus 3. Okay, and you want to be very careful that you make sure and show all of your answers written out completely. Okay? All right. The next example is going to be in table form. So example number 3, we're going to be given a function in table form. So here's our x, and again, I always do mine sideways just because it takes up less room on the paper. Here's my f of x. I'm going to have a negative 4 and 16. I'm going to have a negative 2 and 4, 0, which is nice and easy to write, 2 and 8, 4 and 9, 5 and 25. Okay, so now I'm going to evaluate my function, but I don't have an equation to substitute things into. Everything is going to come from the table. So I want to find x if f of x is equal to 4. So if I look at my table, if f of x is 4, that means x is a negative 2. So I would write x is a negative 2. For b, I want to find x if f of x is equal to 9. Well, in the table, here's the f of x is equal to 9. So then that means that x is equal to 4. And then for c, I want to find f of a negative 4. So negative 4 is going to be my input. This is my output. So f of a negative 4 is equal to 16. And then D is going to say find f of 5. You can't see that, sorry. So at f of 5, 5 is the input, 25 is the output, so f of 5 is going to equal 25. So sometimes we can evaluate a function coming from a table. We can also evaluate a function if we're given a graph. So for example number 4, I'm going to be given a little parabola, and it's going to have an x-intercept at negative 3, 1 at positive 3, and then a vertex at a negative 2. So it's going to look kind of like that. Okay, and then I'm going to have values 1, 2, and 3. Alrighty, so if I want to find f of 0, I look on the graph. Remember, the input is x. When x is 0, that means the y is a negative 2, and so I can write down my negative 2. If I evaluate the function at a negative 3, and technically it should have crossed right there at a negative 3, when x is a negative 3, the y value is 0, and then I can do f of 2, and that would be if I have 1, 2, and then I needed to put that number on there, it's going to be, well, you can't see it, sorry, it's a really crappy graph. We'll just make the point bigger, okay? But you get the general idea that it's a negative 1. So on your homework or your bookwork, the worksheet that you do that will correspond to this, the graphs are on a nice grid, so these points are easy to find. So we've looked at several different examples. So we've evaluated functions algebraically. We've also done evaluation from a table. And then we did our last one from a graph. The graphs that you will do on the worksheet will just look much nicer. So our last example for today, example number 5, says use your grapher to find a table of values for a given function. So we're going to be given that f of x is equal to 4x plus 7, and I'm going to be given an empty table. So I'm going to give you the table. So here's my x, here's my f of x, and I have a -3, a -1, a 0, a 1, and a 3, and the directions would say fill in the table. I could do this algebraically, so I could substitute a -3 into the equation and do it by hand. So if I did f of a -3, it would be 4 times a -3 plus 7. So a -12 plus 7 would be a -5. So I can do that math by hand, or I can do it in my calculator. So when I manage my calculator, I'm going to go to my y equals, and I'm going to clear everything that's there, and I'm going to put in my function. So I have 4x plus 7, and then I'm going to go to my table set, which is up above the window, and I'm going to tell it to start at a -3 because that was the first value in our function. And yours probably has your calculator in auto. If it doesn't, you can put it there. Now I'm going to go to the table, and I'm going to write down the values because my calculator is telling them all to me. At a -3, I got a -5. At a -1, I got 3. 0 was 7. 1 is 11. And then down at 3, I get 19. So your calculator is calculating all of those values for you. Let me show you another way to use your table, okay? You can't see the calculator. So I'm going to go back to my table set, and I'm going to tell my calculator to ask for the independent variable, okay? So now when I go to my table, second table, there's nothing there. And if you'll look at the table that we have in our paper, the first x is a -3, so I tell it I want to use a -3. Remember, negative is the button at the bottom, not subtract. And when I hit enter, it tells me that the y value is a -5. So then the next x value that I would put in is a -1, and then a 0, and then a 1, and then a 3. So you can use your calculator in a variety of different ways to help you evaluate a function. You can either do it with your table in ask mode, or you can put it in auto. If it's an ask, you can just put in the numbers that you want, and you don't have to search for the numbers that you need. So either way is appropriate. Both are really handy. All right, my dears, that is it for today. I will see you soon.